All right, in this lesson, I'm going to talk about similar polygons. Okay, so first we need to talk about what that means, the definition. So polygons whose corresponding angles are congruent, whose corresponding sides are proportional, are called similar polygons. So all that has to be true. The corresponding angles have to be congruent, and the corresponding sides have to be proportional. Let's think about what we mean by proportional, so two ratios that are equal. If all that's true, then these are similar polygons. So the first thing we're going to do here in these first couple examples, we're going to determine if the polygons are similar. Okay, so I can see that the angles are marked congruent. So then what I have to do is I have to check the ratios of the sides, and I need to check that they're proportional. So if I am checking the side lengths, I'm going to start with the small rectangle here, 2, and I'm going to put that over the corresponding side, which is 6. And I'm going to check to see that it's equal to, that ratio is equal to the other ratio, which is back to small rectangle, that's 5, over 15 is the corresponding side. So I'm going to, of course, simplify both of those fractions. 2/6 simplifies to 1/3, and 5/15 also simplifies to 1/3. So because those are equal ratios, we have a proportion, which means the sides are proportional and the angles are congruent, which means yes, these two rectangles are similar. Let's take a look at the next example. So once again, I have the angles are all being marked congruent. Let's check the ratios to see if we have a proportion. So I'm going to start with the 4-inch in the small trapezoid versus the 6-inch is the corresponding side. So let's look at 3 back to the small trapezoid over the corresponding side would be 5. So I'm looking at 4/6, which simplifies to 2/3. 2/3 and 3/5 are definitely not the same. So because those ratios are not equal, we don't have a proportion, which means that no, these trapezoids are not similar. Moving right along to the next example. So we have polygons that are similar. In other words, we're being told they are similar, which means all the angles are congruent and the sides are proportional. So we're supposed to find the scale factor of the smaller figure to the larger figure. Right, so when they're talking about the scale factor, basically it's just a ratio that's been simplified. So a simplified ratio, a simplified fraction that relates the one figure to the other. And this says that we're supposed to go from the smaller to the larger. So if I'm supposed to go from the smaller to the larger, that means I'm going to start with the rectangle here on the right. And I'm just going to pick a side, any side, it doesn't matter. I'm going to use 2. And I'm going to put that over the side that is corresponding to that, which would be the 5. Okay, now I don't have to check to see if that's equal to 4 and 10, 4/10, because I was already told that these figures are similar. These polygons are similar. Remember, if I was checking, I would compare 2/5 to 4/10, and by the way, 2/5 does equal 4/10, so yes, they're similar, but we already knew that. So 2/5 or 4/10, which simplifies to 2/5, that is the scale factor. So you can either call that the scale factor, or we sometimes call that R for ratio. Okay, and we also can write that not only just as a fraction, but we can write that as 2:5. Same thing. Okay, so that's our scale factor. Next example. So once again, we're told these polygons are similar. We're supposed to find the missing side length. So we're first going to figure out the ratio, the R value, the scale factor. So I'm going to start with this triangle here on the left. I'm going to start with 2. I'm looking at the corresponding side, which is x. And I'm going to set that equal to, back to the small triangle, 3 over the corresponding side is 6. So now that I have a proportion set up, I'm going to go ahead and cross multiply that. So 2 times 6 is 12, and 3 times x is 3x. So 3x equals 12. Dividing both sides by 3x is equal to 4. And by the way, the scale factor there would be, didn't ask for this, but the scale factor would be 3. Okay, so from the one triangle to 6, which simplifies to 1/2, that would be our r. Okay, so I'll just get rid of that r down here. So 1/2 is the scale factor, and the missing side length is 4. 4 units, whatever those units are. Okay, next let's take a look at example 4. So we have similar polygons. We're supposed to find the missing side length, and we're told the scale factor from A to B, so from right to left, is 2 to 5. So I'm going to use that scale factor, 2 to 5, and I'm going to set that equal to, well, I don't know x, and that's in the smaller rectangle, so I'm going to put the x with the 2. And I do know 7, the corresponding side, and that's with the larger rectangle, so the 7 goes with the larger number of the 2 between 2 and 5, which is the 5, and x goes with the smaller number of the 2. So now I can cross multiply. 2 times 7 is 14, and 5 times x is 5x, so 5x is equal to 14, which means x is equal to 14 divided by 5, which is 2 4/5. And these are centimeters. 2 4/5. Okay, so that is the missing side length. Next, let's take a look at this other example. So this time, once again, we're given a scale factor 3 to 4. So I'm going to go ahead and write that. I'm going to set that equal to, going from small to large, left to right. So I'm going to line up the 5x minus 4 with the 3, and I'm going to line up the 8 with the 4. So I can cross multiply and solve. So 3 times 8 is 24, is equal to 4 times 5x minus 4. I'll go ahead and distribute that 4. So 4 times 5x is 20x. 4 times negative 4 is negative 16. So 24 equals 20x minus 16. So let's subtract 20x from each side. Or actually, let's add 16 to each side. Adding 16 to 24 gives me 40. And then I'm going to divide each side by 20. And getting that x is equal to 2. So we were supposed to find this, the scale factor we were given, we were supposed to find, let's find the missing side length. I'm not sure. We don't have directions here, but let's say that once we find x, let's get the missing side length. So that would be 5 times x, which is 2, minus 4. So that's 10 minus 4. That would be 6 inches, would be the missing side length. Okay, now you're going to try some on your own. Good luck with those.